Welcome to the Distinguished Guest Lecture Series. We're fortunate today to have Dr. Douglas Engelbart. This is the part of the celebration of the 25th anniversary of the invention of packet switching and creation of the ARPANET. And one of the key people here is Doug Engelbart. Now, in Doug's own words, well, he's most known probably for what he says is he's credited with inventing the mouse. Actually, he didn't invent the mouse. He invented the XY position indicator for a display system. Now, you've got the acronym, of course, right? You can see that's the mouse. He's a very innovative guy and a very inspirational innovator, and in fact, inspired by his invention of the mouse, we can say that, and some work with Gray Walter and some other people, a few people in this area had to invent the turtle. And we did, at least over here, the first RF turtle. And we owe that to you. That was 68. When was the mouse, actually, invented? In 64. Took us a while to catch up, almost. Dr. Engelbart has been involved for a long time in pioneering the kind of interactive environments that we take for granted today. And he did most of that work while at the Stanford Research Institute across a number of years, where he directed the institute from 59 to 77. And he's gotten many awards for the innovative work he's done there, including that he's a fellow of the American Academy of Arts and Sciences. He's a recipient of the 1994 Price Waterhouse Lifetime Achievement Award, the 1993 IEEE Computer Pioneer Award, and the 1991 Coors American Ingenuity Award. But I tell you that, you know, as you can see from the abstract that went around, he is not going to give a nostalgia talk. He's not one, I think, to rest on his laurels. The impression that I have from getting to know him some is that he's always moving forward, and he's very interested in helping to create a better intellectual, organizational, and human future through knowledge technology. So it's with great pleasure that I give Dr. Douglas Engelbart.
Thank you. Is this working? I have it turned on. Is it coming through? I personally would rather sit here and listen to Wally, but I guess he finished that. Well, one of the things I wanted to do today was try a different mode of communication. You know, I've been for so many years standing there pointing off and talking about sort of what we could do in the future. And so people keep telling me, well, you know, you generalize too much, so no wonder. And then I faced with this real worry about, well, how else are you going to talk about much of the future if you don't generalize and use terms that aren't really there yet? So I've never really resolved that problem. But what we did learn through many years of what we've been up to is that some experiences can really make a difference. So I was going to talk about what kind of differences in the way of thinking or conceiving about not only the future, but how to get there and what it might look like. What those differences that I've detected must be different in the way I think from the way other people think. So I was going to try to explicate those to you and show them to you in this nice, dear old system called Augment that we still keep running on, would you believe it, a DEC 20 we operate still. We have recently, several months ago, started to get some money from ARPA that's going to help us bring it a little bit out of oblivion and put an interface on it that is more like what people are expecting to see today, and then slowly start replicating it in a prototypical way that it can sort of merge with World Wide Web things. So one of the things, we've got part of that done now, and the interface client that can run there, and so great, I was going to use that to show you guys. And here are a lot of little things in our system that are different, and that they don't look like all that much, but pretty soon they add up to be a different environment. Unfortunately, I'm not sure. There are a couple of details in there that the controls of it end up just enough, not like I'm used to flying, that I'm not going to try it, fly around in there with you, because it's supposed to be showing you how easy and fast you can work. And every time I turned around, I was spilling the water. I was tripping on it, see. So we made this very reluctant decision that I'd fall back on other AV stuff and tell you about it and try to communicate some in words, and then just, say, we had the guts that we were going to show it to you, so believe us that it probably was different. So anyway, what I will use is a set of presentation materials that we worked up in an application system called the Macromedia Director. It runs in this laptop Macintosh, and it gives a good way to describe the differences in thinking and dives down into some of them and gives you a map of what in the end was what I call a strategy. I call it the bootstrapping strategy because 30 years ago I was thinking of, well, this challenge of augmenting human intellect, whether it's individual or collective, is really very complex. And that's why I started in all the thing in the 50s of saying, well, mankind's problems are getting increasingly complex as it gets more and more global in nature. And the time in which you need to resolve these things is getting longer. And the fact that we're collectively getting global means that pretty soon the society can't really make big mistakes like it can when one culture can extinguish itself in outer Mongolia and the rest of the world of humans around don't notice it very much. The whole world will come down pretty soon. So that it's very, very important if there are ways to improve the collective capability of people to handle complexity and urgency, that we get about it. So that was the driving force, and I zeroed in on computers somehow. I didn't know anything about them but what I read in one book, but I'd been a radar technician in World War II, and really knew that all these signals from radar ended up being on oscilloscopes, and you could put all sorts of things on there. And if a computer could punch cards or print, it could put anything you want on the screen, and certainly it could sense any of the actions you do, so it could real time be responding to you to do things on the screen. And just think of all the neat kind of symbols you could have and how fast you could manipulate them. And other people could be sitting at similar consoles tied to the same complex and starting to find new ways to work, new ways to think, new ways to portray and symbolize. Oh boy. So that, would you believe it? Here I was in Palo Alto thinking about that in 1951, and the nearest working computer was someplace. I never was sure whether Cambridge is closer to California than Baltimore, Maryland. But anyway, there was a known computer in each of those sites, but that's how near they were and how primitive times was. And somebody's talking about doing interactive computing. Well, I think that gives you some sense of calibration about how realistic I am about setting goals. And so I found out when I was getting ready to do a thesis, I quit my job and took my unsuspecting young bride to Berkeley, and they were building a computer. And during all the years, 5 years I was there before I got my PhD, it never quite got working. So, and believe it or not, I was just realizing the other day, the last computer programming course I took was back there about 53 or 4, and we were programming in machine language, and the professor was talking about someday they're working on things that you'd call symbolic assemblers, and even more elegant to be a compiler. So we would write it in machine code, and the way we would debug it is to give it to each other, see if the other guy could find any logical flaws in your program. So imagine now I'm supposed to talk to people that are doing small talk and things like that. But I picked up a few odds and ends on the way. But anyway, all the time, somehow the image was very strong in me that was a potential and would be worth a great deal to explore it. So I was told at Berkeley, finally I got my PhD and was an acting assistant professor and helping teach the first computer courses, even though there weren't computers to use, that somebody really finally got through to me that if I kept talking about the kind of things I was talking about, I'd be an acting assistant professor forever, because there's this thing called peer review and judgment and so on. And none of your peers is going to give you any marks at all if you go around talking like this. In fact, it'll be embarrassing to us. So I decided, I sweated it out and decided that goal meant something organic to me. I couldn't give it up. So I got a job at SRI, in spite of somebody telling me, well, if you're interviewing here, don't tell anybody else what you really have in mind. See? So I did, I didn't, and I did. I didn't tell them, and I got a job. And so it ended up that 3 or 4 years later, working for research in componentry, I got more patents and got on national committees and had a really nice rating. And then I said, well, what I really came here to do was, oh, well, we'll give you quarter time or something to do it. And so the first memorandum that I wrote, about 20 pages, and I took into the manager of the laboratory. His silence. He said, better let me read it. So I came back later. He said, geez, Doug, you really, we somehow rated you so high in being able to explain things quickly and simply, There's 20-some pages, and I read it all the way through, and I still don't get it, what you're talking about. He said, look what Bill did. 1 page describes the project, what he's going to do about it, and it's a 1-page proposal. Now, why couldn't you do that? See, well, the thing is, like, how are you going to tell people about what's the equivalent of word processing, or any of the things, sharing, integrating, working with computers together, if there was no concept and there was no vocabulary to use? So you'd have to use a paragraph or so to introduce a concept, and then later, you can't use a single term anymore. That's too fast. So it just gets very wordy to try to paint the picture of things for which there aren't existing terms or ready-made concepts. And that was the first lesson that's been repeated to me over and over and over again for the intervening, what's that been, 35, 36 years. See? That the way people are already thinking about something affects very, very much what it is they're able to think about in the future, see, something different. So that means that in the norm, if you catch people that are sort of unsuspecting and they're working and there's sort of a clear picture of their environment and a fuzzier thing around the outside of that if you happen to land in there, they can probably stretch to kind of get it. But otherwise, it rolls off. It's sort of like, why should I stop and worry about what he's saying, because it doesn't relate. See? So I've had the same experience when other people have come to me in waiting, and then a few times, very, very educational, that I would realize, my God, they were right, and I didn't hear them. See? And so it's a basic human capability about that the way we think about things right now affects very much about how we can think about the different stage. And so, the word paradigm, I guess, was started to be published about 62 when Kuhn wrote his first book on, what was it, scientific innovation or something. But watching that through the years, and the issue about operating with different paradigms has just hit me like lightning over and over again. So I began to realize, it's really a, let's turn this, I was told they'd be listening all the time. Well, anyway, what do I have to do? Hey, Dave, is anybody there? Oh.
Right here. That should do it. I think it kicked in the screensaver.
Oh, no.
Hopefully don't bump any of the cables underneath your table.
Well, can I?
Modern technology
Let's
at work.
stay here while I move it a little bit to make it. All right. Okay. That's great, and the screen didn't move, so. No, it's so anyway, the issue of paradigms, what I've finally come to realize that's the single most critical issue in our society about our societies being able to adapt effectively to the changes that are occurring. And I'll show you later sort of more about where I got those feelings and all, but I finally made this sort of paradigm map, and I did it to try to help explain to people where I'm coming from and why, when I get down to here, following a trail of different sort of ways in which to look at a problem and stuff, when I get down into here, the kind of technology I build and propose and such happen to be different because of this and because of this, etc. So I can highlight them that this Kodiak thing, well, that's the set of capabilities that I feel are extremely important collectively, and that yes, they have to be globally important, interoperable, and I show examples, and that leads to something called an open hyperdocument system in here. This thing went to sleep. Anyway, so this progression around here leads to a technology proposal that I make. And so if I just walk up cold to somebody and start proposing, I do this, they'd say, well, we're already working on multimedia. And for some reason that would be the end of the discussion, because they were working on multimedia as they thought the next step of integrating that into packages that you could portray to people and manipulate. Or we're already working on hypertext. See, and I'd say, well, see, it's important if you're going to work on it that you sort of obey this kind of challenge. Oh, well, no, let's see, one thing at a time or something. I said, well, it's sort of like trying to build a new kind of automobile that somebody could tell you wouldn't work on the highways, so what are you going to do with it? See? And then I says, well, it comes down to kind of defining what kind of capabilities. So I finally aggregated the kind of capabilities I feel are critical and essentially add up to be collective intelligence, collective IQ. Well, why did I pick those? Well, because there was a strategy for how you could go about it, and that if you aimed at Kodiak first, it would really be a way that you can get the most kick out of a strategy. It's like an investment strategy where you can get compounded leverage on what you're investing. You walk up to people and says, hey, I hear you're the one investing in improvements in your company. Would you be interested in a strategy for the way you'd invest in improvement? If he were responsible for investing in the pension fund, investing it out there and wanting to get maximum return, boy, he'd have strategy and he'd be willing to talk. But nobody talks about investment in an improvement strategy, or how to improve the strategy of how you invest. So there again, it's like if you're talking about that, it doesn't fit people's images. Well, why am I talking about that? Well, it really came out to be, is there a useful investment criteria? Well, why is that? I said, well, if you're going to put in a lot of money in trying to do these things, what capabilities are going to yield the most payoff? So that yields to the, results in this chain of considering about investment strategies and the bootstrapping and so on. Hey, well, okay, well, why make such a big deal of it? Well, let's go back here and say, what was my objective? Well, it really is boosting the performance of organizations in this collective knowledge work. All right, well, very early then, to me, I said, well, that really means there's a whole infrastructure of capability within any organization by which it does almost anything that's basic to the organization. And people who program a lot really know that of all the levels inside the system and the infrastructure of procedure capabilities that you end up building in there so that you can get an effective program run. So it's not hard for them to realize that, well, in order to do a collective design, you have to put together committees to work on. Well, what's the concept of a committee? Or even the way committees meet, or do their recording or dialogue, or design. Or just at every stage, there are lower level capabilities that you aggregate in order to do that capability. So you look at that a while and says, well, there's something different. Well, why do I make a big point of that? Well, because probably about 1961, I'd had a year of a several-year pursuit where I'd run into so many these paradigm shifts already, and I'd read such an interesting article by a couple of executives from Rand Corporation that wrote a description about the problems of organizing and managing a multidisciplinary project. And they says, God, you'll find guys from discipline A or B or C will come to you and they'll say, hey, we already are working on that. We've already got it going, so why are you guys who don't know anything about this in our language, you're working on it when we're the discipline that should work on it? And you try to tell them it's a really bigger collective picture, so we need the other disciplines. Well, And then he says it's very hard. What you have to do is get the people to have a common conceptual framework. And this isn't something, he says that when you grow up inside a given discipline and go through the professional schools and all and get out working, you're imbued with a particular conceptual framework about how you talk about problems and deal with them and the process that you go with. And that you don't realize you do, but that's the way you hear, that's the viewpoint or standpoint from where you hear and understand or don't understand what other people from different disciplines will be telling you about a problem. I don't know what they're getting all upset about. You know, we're already working on that. We already got the vocabulary and we've given 6 papers already about it and such. And it's sort of like somebody who's got a new idea for the architecture of a building. And the guys who are building elevators say, hey, you know, we're already working on that problem. And he says, yeah, but, you know, there's electricity and all of that too. Oh, well, you know, we've... So they said the important thing that you have to do is go through a process, a pre-research process, let's call it a search process, and create a common framework that embraces the problem in enough generality to deal with it effectively, and then bring those people into that framework. And I says, oh, that's been my problem, huh? You know, I remember once I was invited to give an address to some people at Stanford. They had an Institute for Advanced Research in Behavioral Sciences or something that people would get fellowships to and come for a year. Most of them were liberal arts, sociology, anthropology, and so on. And so I thought they'd like to hear about what you could do in the future about computers helping people think. Well, afterwards, sitting around in this California external patio, these 4 guys started really beating on me, and one of them was angry. They were people that specialized in information retrieval from the library world, and they said, look, all you're talking about with your interacting with the computer is information retrieval. That's all you're talking about. And he said, we're already working on it. You're trying to tell us things. You're not even a qualified person in this discipline of information retrieval. What are you doing? He says, you're going around spreading the word, making people think we're not working right. And he was really angry. What could I say? You know, I was picturing the kind of interactive thing of diving around this world and working with it, and that retrieval is not their kind of retrieval at all when you're going and hunting this way. Yes, you'd like to have their kind, but it's like the elevator inside the big building. It's just part of it. So that I found that, and if you'll really pardon my expression, and if I get personal with some of you, I have to say that I also ran across some people from a discipline called artificial intelligence. And they had that same feeling. And I don't know how many of you knew Alan Newell, but how would you like to stand there with him this much taller than you, red in the face, telling you, we're already working on that. My God, we're going to have this general problem solver and such as that. What do you need to fool around with all this stuff for? And I was just trying to say, look, people's processes change, their way of thinking changes, the whole thing of how they want to work will change. It takes that bigger picture. Now, we'll make a model of what the human is and we'll match to them. So every place I turned, I found these different ways of looking that made an outcast of me. So it was extremely lucky that I got some money from one of your graduates, Joe Licklatter, who called himself Lick all the time, who came to ARPA to, he said, we're going to do man-computer symbiosis and time sharing, and here's this guy way out there in Menlo Park waving this thing all the time, so we have to give him some money. And a few years earlier, I'd been turned down for a grant by the National Institutes of Mental Health, who were giving research on computer stuff. And they said, well, gee, it's kind of an exciting thing you want to do about this augmenting stuff, but you're going to have to do some pretty sophisticated computer programming. And this is in writing. And since you're way out there in Palo Alto, we don't think that you can find the computer programmers to help you do what you want to do, so we don't want to invest money in it. Well, they may have been right in that day. So anyway, this is the kind of thing that I finally got some money in the late 50s from the Air Force Office of Scientific Research, who, when I found out the rest of the people that were in their stable, I was sort of feeling, boy, they really are taking a bunch of far-out guys and investing in them. And anyway, then I generated this conceptual framework, and I published it as an SRI report in '62 called Augmenting the Human Intellect, a Conceptual Framework. So in that work, what I really sat down to start thinking about saying is, you know, that's right, we already are augmented. It doesn't mean we already have people who are looking to say, how in a general basic sense do we improve the augmentation of our basic human capabilities? So by that I started trying to characterize it, saying, if you take a newborn human, and if you don't give him any enculturation, any socialization, any training, any education at all, by the time that person's 25, what would that person be able to do in our society? And he says, zero. You know, and he says, all right, look at all the things that that person has absorbed and has available by the time he or she is 25 and a functioning person in our society. All the things that you've added to that basic human being, and call that an augmentation system. That augments that native capability to provide a functioning entity that has these kinds of skills and knowledge and training and conditioning and all, and has the tools. So you start listing those and you realize, my God, there is a great deal already augmenting humans. And here I'm sitting here all smug thinking this technology is going to do it, where it's just a new blip in the evolution. But that really got me thinking. So let's just take a look at that. And so we can dive a little deeper under here and say, this is the kind of thing I drew for myself. And it wasn't long, like an hour into listing the stuff, I categorized it into the two things, saying one side is the sort of technology facility stuff we are available with, and the other is all the non-physical kind of things. So I gave them the name of tool system or like that, or human system. And I says, you know, most of us don't realize how much invention has gone on over here, and that if it weren't for the way all of this is organized, we wouldn't be able to take advantage of the technology we had in 1960s, see? And so I started making to myself a sort of a picture as different things from the very beginning started to emerge over here. You know, making clothes, making simple tools, that are facilities, huts and how like that. How as each one of these improved over here, how there'd be significant changes over here before you had a stable parallel pair that was coping well. And so we get imbued in this, our world, about progress as all the things we talk about over here. But you look at any major change, and say printing press is a very good one, that it wasn't until there was a concurrent sort of collateral, really readaptation over here that it could harness the printing press effectively, or the telephone, or any of those things like that. And when I thought about the computer, I realized that by then, I had gotten some research money in the 50s, where I begun to think about, people were then talking about miniaturizing things very much, and it didn't take much to realize that with the industrial, commercial, military interest in digital computers, that there'd be so much payoff for getting it smaller, faster, and cheaper that it was inevitable to do that. But then that meant smaller and cheaper. So I got some money to say, let me do some basic studies about the dimensional scaling of devices, specifically electronic devices, to talk about, as you reduce them in size, what are the opportunities and the problems and the challenges. And it turns out there's a whole domain in physics having to do with dimensional analysis, dimensionless numbers and things like that. Probably a lot of you have heard about the Reynolds number that they cite in aerodynamics. Well, it turns out if you get an arrangement of the variables such that the dimensions all cancel, and it's a dimensionless number, that's one thing that stays the same as you scale. So they'd look at scaling things like that and says, it's all right if we change if we change the dimension, as long as we change the air velocity and the temperature and everything else so the Reynolds number stays the same, then our model will give us relatively effective characteristics of the behavior of a wing foil or something. So you find out, it starts to tell you something about dimensional scaling, and it was a real eye-opener for me. And it's had a lasting impact in two ways. One, I just became totally convinced that the threshold for smallness of electronic components was just going to go shh. And that what we know now, which seems very dramatic, that at some stage in getting smaller, you got to give up the semiconductor sort of thing, because the voltage at the barrier is fixed, but the current gets smaller and smaller, the impedance level goes up, things like that when you get smaller. So there'll be a limit. But other things, see, at a small enough scale, things can heat up and cool off in fractions of microseconds, see, or physically they can move. Or field emission is something that works quite dramatically at very small spaces. It doesn't take much voltage to get field emission out of things. So there, you just say, the thing about it was that every different scale, physical scale, there's a different relationship between a lot of the phenomena which occur, because some of them will be dependent upon volumetric effects, some on surface area, some on linear, and they all change differently. You know, one with the linear with scale change, one with the square of it, one with the cube of it. So if you've got a device that depends upon the inner working of phenomena in which the phenomena don't shift the same with scale, pretty soon you'll get a place with, as you just change the scale, that device won't work the way it was designed. On the other hand, other things open up. So that whole thing was a really important thing for me to realize, that the assurance with which I could go forward and invest a career in things that depended upon lots of computational capability coming up and cheap, I said, boy, there's no worry. It's inevitable that we're going to be down small, so that, and you know, and even my friend Al Newell, even though he got mad at me once in a while, we're friends, but I heard him give a talk in about '69. He was saying, well, it's going to get so small you can paint it on the walls. See? So, though a lot of the investment in long-term computational things were being done without that sort of picture, for one thing, see? Which is another aspect to go. So that assurance I had, I said, okay, I'm committing really more. I'd already been at it 8-10 years. So anyway, the other thing it taught me was a surprising change in the qualitative character of the set of phenomena as you changed in physical scale. It was surprising. See? And some people in biology did some fun things, writing papers about changes in scale and pointing out that a flea, you think a flea must be constructed tremendously to be able to jump as high as it can. No, it turns out that if you change your scale, how high you can jump doesn't change because of the balance between muscular strength and muscular energy stored and the energy it takes to propel you up and all that. Similarly, gravity starts having less and less effect. Like an elephant falls off the stage and it's probably critically wounded. A mouse falls off and it gets up and runs away. A mouse falls that far. I'm sorry, I just happen to use this term, mouse. You know, the same thing, you look at mosquitoes, they're very, very spindly legs and ridiculous little wings. How can they fly? How can they stand up? Well, at that scale, you hardly need any wings at all. And gravity becomes so much less. And one of the enemies is surface tension of water. See? So that I would tell people, if you were made about a 16th of an inch tall, what do you think the effect would be? Well, you'd be horribly over-designed. You wouldn't have to have anything like the same girth in your size and muscles to function. And you could jump and you could run and everything else like that. But boy, don't try to get a drink of water without a straw. And why is that? Well, for one thing, you couldn't break the surface tension with your face. What do you mean? Well, that scale of surface tension is a big deal. See? Well, boy, I'd ram my face in. I'm that strong, yeah? And as soon as you got wet, boom, you couldn't get out. So you'd be drowned. You know? So there are a lot of things. You see that qualitative change in the environment just really got hold of me. I entertain people by saying about different things if you change their scale. Like I gave one talk in front of a whole bunch of device engineers. I said, what if you and everybody else and everything else in the room suddenly got larger by a factor of 10 in every dimension? Would you notice? And most people think of the eye effect, that everything would have the same perspective angle and such. You probably wouldn't notice, would you? See? Except your chair would break. Because effectively it would have to have been designed for the safety factor of over 10 in order to hold you there. Because it turns out the cross-sectional area determines the strength, and it would only go up by 100, while your weight went up by 1,000. And if you were on the floor, you would have broken a lot of bones in falling that far. and you couldn't pick yourself up because you don't have a strength factor at more by 10. So a few things like that. So anyway, that qualitative nature was really in there strong. And so when I looked at this picture here, well, it's a nice thing that I talk instead of depending on this, isn't it? So, but you have to have faith that the technology of the future is really going to be working. All right. So, but one of the things I was going to show you in the kind of hypertext world we've been living in, you can link between messages, etc., which is a really nice thing. And then I was going to show how you could sort of analyze the issues that went through a series of interchange of messages, so you could sit there and point to them, or you could show how a message, instead of, if you want to respond to somebody's message, and a lot of times people copy a paragraph or two and it comes through with all these little wedgies, and then they comment, well, you can just put a link in there instead, see? And so I was going to sort of do all that, but so I was taking this series of interchanges, and it turned out there were about 25 messages it took. These guys were trying to say, do you really want all the things we wanted set up to connect to the network here and telephoning and everything else? Yeah, so anyway, that's what just reminded me. So I really have to say that I think they're extremely cooperative, and they set all this thing up, and now we can't use much of it. So that's why if something jams up, because under this table there's about 12 times as much hardware as they would have had to have if they were just going to support this. See, so be nice to them. They were nice to me. So anyway, looking at this then, and realizing something over here, that the scale of change in speed and cost and bandwidth, etc., over here for handling things that we'd always been handling with like paper or something, or telephoning or telegraph, the scale change on this side was going to be immense and wasn't going to stop changing for decades as things got cheaper and cheaper and cheaper. And, it's hard to do otherwise, but we all keep thinking about what we'll do in the terms of, well, we've got laptops and maybe personal assistants, etc. now, but it's just inevitable. It's going to get so you can carry around something with all the power you could possibly absorb, and it'll be wireless connected all the time, etc. And then you'll say, well, a few decades later, it could be surgically implanted in connecting to your nervous systems. Either the potential, those are all just inevitable way the technology is going to go. And, well, you could hear me now and say, oh, hell, I came all this way to sit and listen to this. Well, 30 years ago, I was telling people, look, it's absolutely inevitable that on every desk, a knowledge worker is going to be able to have a terminal that's alive, connected to the computer. This technology is going to go there. So, why set aside your interactive typewriters for one thing, and but things like that just sort of set you aside a little bit till you get treated like somebody who's a rabid political extremist on either end, and you see him coming, and he says, "Oh God, no, I know what he's going to say." And it's ridiculous, so you start avoiding him and you don't answer his phone calls and such. So I found myself being treated like that. You're a nice guy, Doug, but geez, you sound like all the other charlatans. So this one guy actually told me that, friendly way. So anyway, the thing about this is what really struck home to me, was that change in scale here and the inevitable massive rearrangements that would go on in this human system side. Not to say the bad technology forced it on us or something, but to say if the humans want to take advantage of the potential that's over here for human ends, they'll have to make a lot of changes over here in order to harness it effectively. Okay? So in the mid-70s, we were met by this huge wave of things, office automation. We're going to automate you. We're going to automate the factory. And you're saying, oh, no. These methods, customs, processes, procedures, and all that. You don't want to automate today's. You want to do this. So the whole thing about the co-evolution of these things, that nobody is smart enough to go ahead and redesign this as an open-ended thing and say, that's the way it's going to be, so let's design the tools and get this system going. what you have to do if you want to make an improvement is try to find a process of pragmatic coevolution of these two sides. So I said, all right, pragmatic coevolution, and that's the term. So that's in this framework paper, that just hit me so hard. And I said, you know, that the process of changing over here is serious. And why is it that we don't have disciplines in universities and so on like that treat this whole system? We have engineers and all kinds of things over here. We have sociologists, organizational development types, cultural anthropologists, etc., dealing with things over here. But why isn't there one dealing with the architecture of this whole thing? Like for a house or a building, where here's all the hardware and stuff, and here are the spaces and the aesthetics, and how I have to provide space for people to have their material on here, and passageway wide enough here, a lot of the things about the human side that's going to go in. But the elevators and the electrical system and the heating and ventilating system and the lighting system and all, you know, lights, and those things all have to be integrated as a whole architecture. So why don't we have people? So I just said, you know, that's an augmentation system, I said, like, and so that's the thing that I'm convinced that there'll come, in which there's going to be people that start looking at that whole system. People doing process reengineering over here are starting some of the things, taking a slice out of here and looking at the changes of that and saying the technology will enable new changes there. But it's really the co-evolution. It's like you start saying what you could do over here would make a difference in the specs you had for the system you do here. But nobody is smart enough to really make too big a projection over here, so that pragmatic co-evolution is the sort of thing. So that was just central to this thing about augmenting the augmentation system. Okay, so that's a fairly abstract thing, and it leads on around here to different designs here and a different sort of focus here. But that's all right. So what we talk about then is going into this co-evolution we were talking about. And one way to look at that is to say, oh, we have these two basic change dimensions that we're talking about. The human system configuration, the tool system, and if we found some very smart way to order the new states that you could get if you made changes that were progressively more payoff, and here if you listed the kinds of new technologies you would add that progressively so that they would be harnessed for more payoff, you'd say, oh, I've got a whole frontier out here to explore that we really don't know. If we're really thinking very shallow in here, maybe a zone that far of the kind of changes we're likely to make and tolerate in our organizations, we're going to explore, and what we would pick to go out here in technology would be very different from what we'd pick if we says, hey, boy, for every degree of technology, I want to explore out here to see where the most payoff would be. And also, so where it is in the future out here that you'd like a particular organization to get is a mystery. It's a frontier. And the thing is, we perceive certain boundaries right now, but in 20 years out, those boundaries are going to go out there where we haven't even really pictured them essentially. So we're not going to be awfully far out in here in 20 years because the time it takes to evolve in this direction here is much larger than the time it takes to get on it. And some digital stuff that's twice the bandwidth, or twice the speed, or twice the memory, like that. So that's the painful part, an expensive part of moving out there. And probably it'll be like a factor of 10 more expensive to make the move out in this direction to a really good new future state than the cost of getting the technology out there. So anyway, this is the kind of thinking that after all these years of pounding away at the idea and experiencing it and watching it and trying little things and learning and watching is the way my perception of it is. So a difference like that of looking at this frontier and feeling like that migration and what's the path of going over, that leads to many other differences in the way I'm thinking, and that's what I advertise for today. So maybe we ought to have a small break and you can leave if you want. If you know what you want. But there are the path of sort of reasoning and trying out things and developing new kind of concepts that try to help fit what you're trying to think about lead you pretty much to being away from the paradigm that you left behind. Then you turn back to tell the people, your old buddies from yesterday, hey, look what I've seen from this viewpoint. See, what the hell is he talking about? See, that's the reaction that goes. And Doug, you know, you are a nice guy, but so anyway, then you try to say, well, how do we get people to climb up here and take a look or something, or listen long enough? Well, everybody's busy, and they only have so much time to listen to people waving their arms and pointing off in directions. So it's a serious social problem that I realize you can't stop and listen seriously to every zealot that comes by, you know. And I've had them come by and grab me by there, and I finally said, I'm too overwhelmed with what I'm trying to do. I can't listen to you. And they go away, and I feel guilty. Jesus, you know, what am I doing to them? But anyway, so there's something about in our society, it's a very important issue that has to do with how do we find practical ways to accelerate the evolution of our sort of collective paradigm about what the future's like, so that we can look at the future in ways that are more pragmatically realistic to what we're going to face next year when we're in the future. If we are solving today's problem, the one we see today, and maybe it's for another year or something as a critical problem, with a way of thinking that's 5 or 10 years out of date, then what do we expect to do with the solution? When we get there, you know, we're already, if we get there in 5 years, we're 10 years out of date instead of 5. So there is this factor. I discovered that the people in financial investment have a very interesting term they call lost opportunity cost. And I realized, okay, that in our society, that if we don't shift the paradigms fast enough so we adapt and work toward it, there'll be a lost opportunity cost. That it's not until we have shifted enough to get an appropriate perspective about the issues we're dealing with, that during the interim we'll be doing the wrong things about solving the problem. So I tried to look around, and boy, it popped up pretty quickly, a couple lost opportunity costs that are easy to point to. It says, today everybody's all hot about networking. Boy, that's really the way to get, and besides the World Wide Web, it's just the superhighway and all that's there. But you know, the people that got the personal computers starting to popularize those 10 years ago, if they'd started out, if they just listened to all the people who are already living on the ARPANET to find out the value in being able to just be able to flip things back and forth between yourself through the networks and such, that they would have started thinking about it. But I literally couldn't get them to think. One very powerful guy in the field, I had half an hour to try, and just, you know, he says, look, time sharing and stuff is bad because you get tied to a big computer and it's overloaded pretty soon and you can't do what you want. Now you have everything you want on your desk, and nobody's interfering with you. You don't want to connect it. And he just was adamant. Well, it must have been an adamant society because, you know, IBM came in, DOS was evolved, everything like that had the slightest orientation towards networking. So, lost opportunity, a decade for our society to start getting oriented about these things of quite effective utility, not to be connected, interconnected. So, it'd be interesting if somebody could calculate what the probable lost opportunity cost was to get our society oriented and started moving that direction early. So there are probably lots of others. So it's a serious issue, and it's almost like saying, if we're going to go out into this frontier, and you're responsible for taking a sizable organization or institution, and you says, boy, I'm listening to the guys from MIT Business School or Stanford Business School or something, and I'm taking this path, and it's like taking a great big long wagon train out into the frontier, and you don't know that you're going up a blind canyon. So just picture the problem of backing up a wagon train 10 miles or something. See, it's the difficulty. So the cost of the lost opportunity of zigzagging is very high. So these kind of thoughts have just impelled me constantly to keep going. It keeps me from retiring gracefully. It's like saying there's a lot to do. And so when I start thinking about this most payoff and asking that question, the investment criteria, and I really get to how does improvement process work anyway, and I realize there are levels of improvement activity that are important, and that, hey, if you address those levels right, you can get a strategy whereby if you've got the appropriate improvement infrastructure in a big organization or a collection of organizations or an industry or country, the very things you're trying to boost and augment could come and improve your improvement process. And it's that kind of multiple leverage that's just had me grasp for 33 years now, is bootstrapping, is it saying, hey, if you go after, if you have the right kind of improvement infrastructure, and you go after the right collection of capabilities to improve, it will also help all your organizations be more effective. But if those improvements can plug into the improvement infrastructure, you'll accelerate the rate of improvement, accelerate the return on anything you're investing in your improvement. So that concept has just anchored me in for years. So bootstrapping, that's why we built what we built back there, and why I keep talking about now, why I named it the Bootstrap Institute, why I come out and try to talk the whole strategy, why I talk about this Kodiak as being important, et cetera, et cetera. So this is what I advertise, is saying the ways of thinking are different. They've got to be different. So what I'd like to is sort of say, well, if we jump down into this, as saying, as far as collective knowledge work goes, the thing that has so much payoff in here, that has some feel like that, of any organizational entity you've got, which almost always has independent knowledge work domains in there. And this image is work for a personal person too, your email, your professional work, your memoranda, whatever kind of things, your to-do list, your reports you're generating, these different domains of knowledge, they should be interoperable, that what you're doing in one domain should be as accessible to that as to any other. And they should also have a lot of coordination. And so one of the things to think about is say, okay, look at your individual or your organization across here, and say you open up the top of that organization, and how much new stuff can you pour in there in a way of knowledge about the world or the needs of the situation? How fast can you pour stuff in there that can be assimilated and integrated now? I'm going to readapt my course of action because now I grok at something different. Okay, that's a lot what you think about an individual human is. You know, how long does it take when you've explained some new situation? They can say, I get it, I readjust my reasoning and thinking like that, and now I can do something. And also, how do you go about internally generating your new knowledge and integrating what's there and such? And with a multi-party thing like that, how long does it take a good idea that's generated here to actually, in a balanced way, integrated in with all the rest of the things that are going done? Or something new perceived from the outside, how long does it take it to go? So we have very primitive ways in the past, if you think about it as a social organism, and say, gee, what about, there could be an equivalent IQ of the social organism, and what can we do to change it? So it's that sort of picture. And actually, when we talk about the CO part of Kodiak, I generally ended up saying it's the concurrent development, integration, and application of knowledge, even though it's nicer in some initial sense to say collective, because collective means that each of these knowledge domain nodes is itself concurrently doing that. The engineering department, the da-da-da like that, or different people on a team, they are concurrently doing that thing for their own working domain, while the whole thing collectively, to act as a collective, essentially is concurrently doing its thing, and it's often part of a bigger one. So that concurrency in there is a factor that affects the requirements downstream very, very large. And it's something where you know it's going to be available in the end, that what the party here, the group here, the collection or something needs to know about what's happening over here is one link away. And and when you get there, what you can do about it. And same with the outside world, what's there about it, and over like that. So you just say, well, what would it take for that human system and tool system to organize until this is really a collectively coherent social entity that has an IQ? Well, the potential is there, it's immense. And also the need, I say, boy, if, you know, every organization that's competing in the world, trying to do its job, if it doesn't keep up, you know, survival for what? Anyway, I just feel it's important. That's what drives me. So, anyway, we go down into the open hybrid document system, and I've visited today with 3 different collections of people, 2 at MIT and 1 collection of contractors, of guys here who have contract with the same ARPA command and control program that we're getting our money in. In each case, there were, we could just go on because of all the questions, interactions. So the time I have with you here is very, very short, and it's you know, one of the things we used to give 3-day seminars to industry and government, such coming in. We're just trying to go through this framework in 3 days, and in the end, it will always be more. And we've been giving courses, 1-week courses that we call the start of an expedition for people to come and learn about how to live in our environment. So, something about our environment. Let's take a look here. Of course, if you're going to do that kind of collaborative work, you have to have shared files. So a lot of the world now with networking has the ability to share files, and I can give you a URL to a file, and then you can bring it in, etc. like that. So the thing that, when I look back at that human system tool system, and said, well, what are the kinds of big changes going on in the human system that would be handy to get started so it could evolve instead of having to make some huge transition? And so I fixed on language. And the thing, what a marvelous invention it was that we invented symbols that we could deal with, and that we have a machine in here that can deal with concepts that can be represented by symbols, and that those concepts can be related so you could actually have grammars and relationships here, etc., that mapped what your structures were here, so you could communicate and externalize your symbols, and all the levels of abstractions that you do in in thinking about things. Why couldn't you make a representation of that in the computer that was a much better model than a document? The same thing. It's an externalized package of symbols. So that's what got me started in doing what other people later would call hypertext and such. It's, oh my God, they're all little kernels of concepts here, and they're not oriented in pages, and they're knit together by a lot of the semantics you have, etc. So why don't we have a way in which those individual concepts can be held in a computer, and you can have all kinds of pointers in there to relate things in any way you want to. So what would be the best way to map things that were your concept structure in your mind out to an externalized form such that it preserved what was important to you to operate on it here? And that then you have that, and you could sort of move around in that the same way you can move around in your mind. So I tell people, well, I want to talk about your car. Boom, there's an image of your car. Oh, the driver's compartment. Boom, there's another image. I meant the console for the controls. Boom, another. I meant your fuel gauge. See, in each case, you don't load car and scroll to fuel gauge. See, you go boom, boom, boom. Or if I just said the fuel gauge in your car, boom, you're right to it. So I said, that's the way you think, and you move around, so let's make it so that you can do that. Pointers and everything, that's no trouble. Well, that's pretty complicated to make that structure. Oh, I know, but the computer can help you make it. The computer can help you view it in all sorts of interesting ways, move around. So it was that sort of picture we started doing in the 60s that led to it. So our picture of hypertext was driven by where the links were just one part of it. And they got to be an important part, and there got to be other varieties of links and such that we involved. And so I said, all right, let's structure them, give object linking, viewing, browsing, shared screens, which is an important kind of thing that we've been using for 20 years. We could call up somebody else, tell our operating system, da-da-da-da, pretty soon we're both looking at the same screen, and you can pass controls back and forth to work on it. So we've been doing that, talking about it for 20 years, saying that's inevitable. See? And the scripting means ways that you have a set of verbs and nouns that you're dealing with in here that not only really make it effective for the way you can manipulate, but can script well. So that's what we did. So, you know, when the rest of the world took the mouse and went to menus and all this easy-to-learn stuff, we kept there with verbs and nouns that you could put in menus if you wish, but it's part of the menu you're thinking about so that your scripting becomes very powerful and other things like that. So the next thing we did, this was like in the late 60s, we were doing that a lot. When we were starting to become the ARPANET Information Center, Network Information Center, that I volunteered for. Exciting, here's a real community that can collaborate. We had an email system working by mid-70s when we got our 10X up going, and we were saying, all right, just like if you would dial in to America Online or any of the other services, people can dial in and work with us in this environment. Like that was part of our idea for supporting the Network Information Center. And something that was even bigger and very, very effective was that anytime you want, you can submit a little shorty or a great big document to the journal that got held, and it would get put in where it was safe, administratively protected as a permanent document. It was given in the catalog, given an identifier, and any time after that, a link that you have that points to any object in there, you're guaranteed that you're going to get back what the author published in there. So then that grew till we had like 20 servers around the country supporting some of the big organizations we were working with, where one of the journals was embracing the whole group, and other journals were just registered on several of the servers. But that kind of thing, that very thing of publishing was just a dramatic sort of new capability. We're trying to tell people that would be very important. And the next stage was managing external documents. But anyway, so we were going to show you a bunch of things in that category. And, but what I really wanted to do is kind of give you a feeling like that a networked improvement community is one of the concepts that comes clearly out in this strategy. It's saying, if you get a bunch of organizations that are going to try to really improve the way they do their personnel services or their procurement or their software development or like that, and you network them together, then there are a bunch of these kind of capabilities in prototype form you could support them with so that they could do the process of collaboratively working on it, finding out how to improve much more effectively. So that's a big one, and it's something about that which we'll get a chance with the ARPA's thing, with software development people, with people doing enterprise process modeling. These are the different categories of kind of community categories that we're starting to try to get interested to participate. And another thing is to get a community that's really interested in really boosting their Kodiak capability. That really gets the bootstrapping going. And so really full bootstrapping would be a networked improvement community whose members of the community were mixed improvement communities on other topics. And so that's the kind of sort of end sort of picture we've been trying to promote and get started. So I appreciate that flowing around with all this conceptual stuff doesn't leave you much. And I'm sorry that the things we could have shown you didn't work, but I think I'll just quit now and that's it.
Thanks very much, Doug. I'd like to remind people that we have wine and cheese across the way and a chance to meet this nice guy. Doug would be there. And he has left some brochures here talking about Bootstrap Institute. There aren't enough for everyone, but those who are interested can come up and get them.